It consists of a cup and a cone. We're going to install the bearing cup into the cover using a post vise. It's done. These are the metal shims that go between the cover and the main case. You use these shims and gaskets to set the bearing preload for the countershaft.
Alright, we're going to start putting on the countershaft bearings. So the first thing to go on is the locating spacer collar. You notice on this one it has a chamfer here. It's got a little one on one side and a big one on the other side. The one with the deep big chamfer goes on against the splines. Alright, Paul, get the roller bearing. Okay. Roller bearing goes on next. Then the spacer. Another roller bearing. The thrust washer. I don't believe the thrust washer has a particular orientation on it, but you can see where this one has been worn more on one side than the other. So I think this is the side that goes to the bearing. Put that on there. Okay. And the next thing is the bearing. We'll have to take it over to the press and press it on. Pressed on the countershaft.
We just used a 1 5/16 socket to press the bearing on the countershaft. We're going to put in the snap bearing.
Goes in a lot easier than it comes out.
This is the left-hand bearing cup, and we're seating it to the snap ring. Make sure to use a soft mallet or a rawhide hammer.
A little ways to go yet. A little ways to go yet. Make sure you use a soft-faced hammer or a rawhide mallet to drive the bearing race in, and use a 1/1000th or 2/1000ths feeler gauge if you can make sure it's not, if it fits in there too easy, it probably needs to go in there a little bit farther. So, I think that one's seated in there pretty good. Alright, we're putting in the countershaft. The first gear you put in is called the countershaft idler gear. So we'll put it in about that far, and then we'll go get the next gear that goes on. The next gear is the first and third gear, and you want to install it with the widest flange here towards the idler gear. All right, the next thing to go in is the gear spacer. It doesn't have any orientation. And this is the differential drive gear. And it doesn't matter, it can go in either direction. All right. The next gear is the 2nd and 5th speed gears. And you want to have the rounded part of the gear towards the left hand side of the case. And then after that is the bearing spacer. It goes in after all that. First we got to put this bearing in here. Then we put this guy in there. Made an error. It doesn't appear that all this stuff will fit in here. I know it will. I took it out of there. Come on. Oh, you're gonna be difficult, huh? Oh, you'll fall out, huh? Alright. Okay. I figured out that I had to have a little more room to get this bearing in here, so we have to back up a step, then put this guy in here. Alright. And we get to line all this stuff up.
Lubricate the bearings with motor oil before installation. Align the shaft and push it through the other side.
Sometimes it's easier said than done. Alright. Your next step is to put this locking nut on here. It's a spanner type socket you use. This is a OTC 7158. This bearing has a little story to tell, and once we get it all put in there, I'll take a minute to tell what I found about this bearing right here. So we're going to tighten it up with this wrench. Paul's going to show you how he puts it in the gear to keep the shaft from turning, and we'll crank that down.
I'm holding these gears with this pry bar, and to keep it from turning, Dad uses his cranks on it.
Well, that sucker's tight now. You ready? All right. When we tore this tractor apart, we found out that the shifter shaft that goes out here to this, there's a gear out here, and has a fork that goes into it right here, goes on this shaft, and this shaft was bent down that shifts this gear. I think it's the 6th gear, overdrive gear or something, I think that's what it is. But anyway, this spanner nut was all boogered up real bad, where somebody had to use a chisel or a drift to try to tighten it up instead of buying the correct socket. Well, most of the time, you know, that's kind of an accepted practice, but the problem with that is I don't know, I know these GoPros are horrible at zooming in, but this bearing here, right here, it's all corroded right here, so it was getting ready to fail. But the bad thing that was really bad was in this bearing right here. This is all scored up right here, and the shaft was scored up. Well, what had happened is this spanner wasn't tight enough to hold this this assembly together. So the bearing, whenever this bearing has a catch in it where it's locked up, and it locked up, and instead of, it basically started turning on the shaft because it wasn't tight enough, because they just used a hammer and a chisel to tighten it up. So to fix this, of course, we got a new bearing. I put this in the lathe and I knurled it. It was probably turned down maybe 1/1000th on the shaft. I think the bearing took most of the brunt of the damage, but the shaft, I knurled the shaft a little bit on the lathe, and I brought it back up to a little more than what it should have been, because it displaces the metal. It makes a deeper valley, so it makes higher peaks in this shaft, so we can displace the metal. And then I got some sleeve retaining compound, and I put on around that shaft, so it's kind of like Loctite, but if that bearing decided it wanted to move, it basically is glued onto that shaft. So once it sets up, I believe that's going to be a good repair economically. I mean, we could probably found another one of these shafts somewhere and probably, you know, been all right, but I didn't think it was bad enough to where we needed to purchase one. This one here could be fixed this way. I would say that if it was a tractor that we was going to, you know, make your living with or something, we would have probably put a different shaft in it. But this is how we repaired it. As you can see, that it pressed on real nice. We put the collar on here, and you can see this dent right here. That is where they tightened up the last time, so we've got it that much tighter this time compared to what they used the hammer and the chisel. You just bend this down into the spline, and that's what locks that from loosening up. That thing, this bearing, whenever we took it apart, that just come right out. It wasn't tight at all. I'd say that this bearing loosened up. It dropped that gear down when they went to shift it or whatever it was in there. It basically bent that shaft because the bearing failed and some stuff got in a bind. This area right here had a bunch of nicks and bruises in the case. I believe this was a failure. I don't know if they went back in here and put another bearing in there and it's failed again, or that's still the same bearing and they've you know, this is what's happened now. I don't know, the tractor's what, 60 or 70 years old? Who knows what happened? But there's one of the reasons why, if you're going to restore a tractor, you tear it all the way apart if you can, because otherwise, man, this thing didn't run too bad and it shifted in all the gears. You know, a lot of guys would have just said, oh, paint it and let's go go to the show. But we went ahead, and that's something that we found that we didn't even realize that we were going to have a problem with. This into the splines so it doesn't back off again. All right, we put the cap on here, tightened it down, and we put in our 4 metal shims and 4 paper gaskets, and then I had another gasket that was made out of thicker gasket material, and tighten this up. Then you go over here to the other side and you set it up with the dial indicator. My old lens is in pretty bad shape. I don't know if you can see it or not. But anyway, you get in here and you move this back and forth. You can see it's supposed to have 1 to 4 thousandths. We have a little bit more than that. I think we got what, about 18, 19 thousandths. So we'll have to go over here to the other side, take that cover back off and take a gasket out to see what we got. So we'll do that and Be back. We need 18, 17, 16, 17. We need a 14 thousandths gasket. So we'll have to measure this gasket and see what we come up with. I'll have to make one that's thinner. So we took a gasket out of this shim pack behind here, reinstalled it, and now we'll see if we can get the, I've got it, okay, we pushed it all the way to the left. Now we're going to put it on the right. So it looks like, okay, we'll get it all the way this way. We'll put it at 0. And now we'll pry it the other way. Don't want to go too crazy because you can, the case will flex, believe it or not. I wouldn't think that it would, but it says that in the book. So I guess if you wanted to get crazy with it, I guess it would. But anyway, it appears we have 3 thousandths. So that's in spec. We're good. Now, this bolt here goes through the main case into the lube. And I'm going to put some Teflon sealant on it. Now, I don't know why they didn't have, they had you put these lead washers on this one to seal it, but from my understanding, that one there is going to be almost right at the same level as the gear lube. I guess they figured that this one here wouldn't leak because it's not just basically immersed in the lubricant for the transmission and differential. I can't really tell, but I don't think it would hurt a bit if we was to put a little something on there to give it a fighting chance of, I don't believe it will make a difference in the, if it was on there. It couldn't do anything but help. So it doesn't say anything in the manual about putting a lead washer on these two. So we'll we're going to safety wire some of the bolts here. Originally had these 3 tied together, but then I figured out that in the other part of the manual, it shows that these 2 are tied together, these 2 are tied together, these 2 are tied together, and then these 2 are tied together. So the engineers from Deere and Company has kept these things running for a long, long time. They probably know what they're doing, so we'll do it their way. But you want to do this in such a way to where you tighten this bolt, you put your safety wire in there, you would want it to go on this side of the bolt. If you put it on this side of the bolt, there's a chance that it would back off instead of, like, to make this come loose, you basically would be tightening the bolt even more. So the way I do it, you have to put it around here like this. Oh, I can't see very good. Still can't see. There, that's better. Put it around there like that, and then I got these. Now you can do this without these crazy pliers, but I bought these at an auction one time, and well, by golly, I'm going to use them. So And basically get it like this and kind of estimate where your next wire is going to be here. And then clamp it. And this has a little piece here that locks this here up, and now you're supposed to have it about like that. I'm no safety wire guru, so correct me if I'm wrong, but I believe you're supposed to, well, that's not good because it's not very tight, but oh well, there we go. Anyway, the twist per inch, there's an actual specification, you know, for machinery or aircraft or aerospace or what have you. But, you know, we don't have to worry about that because we're working on a little tractor. So, have you seen how these were done when I took it off? We are going above and beyond the call of stupid here by doing it the way we're doing it now. So, we come around on that side of it. That way, if we went on this side of it, the bolt could possibly loosen. But now we're coming over here on this side to make it tight. So if this was to try to turn, it would try to turn this way, which is tightening the bolt. We'll get this guy on here. Lock it in, or attempt. Well, that wasn't very good. I went the wrong direction. Let's try that again. That, and this isn't genuine lock wire. I think this is mechanics wire, so. Yeah, the good stuff is stainless steel. And, well, you little dog. This thing just doesn't want to be lock wired. I think it has something to do with the camera. Let's see. Now, you noticed this one has a lot more twists per inch than this. Now, I don't know why that is, but that's what I have been told that you need to do. You cut that off, and you take that little tail and try to twist it right down there like that. That way nobody fillets themselves the next time they're in there. And just kind of smash that down to where it's not going to get in the way. And I got this one here. It's trying to go over the top of the bolt, which isn't good. I may have to redo that, but there we go. There, it popped over. There. That ain't going anywhere.
This is the left-hand input bearing. Install a snap ring.
Drive it into the case. This is the input drive gear. This goes into the right hand side of the case, into the right hand bearing. This is the right hand side sliding gear shaft bearing. It's shielded on one side and open on the other. The manual says to pack this with wheel bearing grease, so I went ahead and packed it. This goes into this bore right here. It's a kind of a slip fit. Of course, you know, it don't want to slip. There we go. It says that the shield goes to the outside of the case, and then this slides into the bearing on the outside. This is the left hand sliding shaft bearing. I got it supported by the inner race here, and I got it started onto the sliding shaft. It just slides down on there like that. Not a big interference pit at all. Come out of our we pressed it on the shaft, so I'm going to get a brass hammer and use that. Brass hammer won't tear up the threads. Worst thing about a brass hammer is it has a tendency to shed some brass whenever you use it. So, as long as you will anything. As you see, things don't work as good as they do on other people's channels with me. But slowly work our way around, and we'll drive it into that bearing over there. When we get that done, we'll come back and show you what we got.
With a little persuasion, the sliding gear shaft is installed. And we also got the snap ring on.
This is the oil retainer. Goes right here. Just fits in the housing just like this. Put it in there till it flushes out against the main case. Good. This here's the input shaft. This is the input shaft bearing. This is the input shaft bearing retainer. It has a gasket right here, so it goes on over that, and it holds the bearing in this recess right here. So we're gonna put that right there. And there's a short and a long bolt for these, because the short one goes over here on the right, because of this is a shorter, and this one here's thicker on this side. So we'll get these threaded down, and we'll put the gear on the other side. We have the 4th and 6th speed gear. I have the there's a key here that keys it to the shaft. This one's a press fit, but it's not that bad. Pretty much went on there pretty easy. We'll get the nut and tighten it up. We're going to tighten up the gear on the outside, and it'll be a lot easier if we get it, slide this in 2 gears at the same time, like this. That'll keep these, they'll bind the shaft so it won't turn. Then, using an 1 7/8" socket, we're going to tighten this guy up.
We got it all tightened up. It's got to line up with this hole so you can put a cotter pin in it. so that the net won't get loose.
These are always more difficult to bend when there's somebody watching.